Find the average value of the function f of x equals x cubed on the interval 2, 4. So we're going to use a little guy called the average value function. Looks a little something like this. 1 over b minus a, where a and b are your upper and lower limit. Then we're going to set up a little integral from a to b of f of x dx. And so it's just a matter of using this guy and plugging everything in. 1 over 4 minus 2 times the integral from 2 to 4 of x cubed dx. So you're going to be a half, right? This guy is going to turn into, what is that? 1/4 x to the 4th with limits of integration at 2 and 4. Okay, so now just more plugging stuff in. 1/2 times 1/4 times 4 to the 4th minus 1/2 times 1/4 times 2 to the 4th. Okay, let's move that up here because I'm running out of space. 1/2 times 1/4 times 256, I think, I hope, I pray, minus 1/2 times 1/4 times 16. I can handle that. PEMDAS, 1/2 times 64 minus 1/2 times 4, multiplication, 32 minus 2 is 30. The answer is B. Look at that. Isn't that fun? Find the average value of the function f of x equals cos x on the interval 0 pi. We are going to use the average value integral thingy-ma-thing. That's 1 over b minus a, where you would be my a and you would be my b. And then we're going to multiply that to the integral from a to b of f of x dx. So now let's plug stuff in. 1 over pi minus 0 times the integral from 0 to pi of f of x, which was cos x dx. So I think I can handle what pi minus 0 is. The integral of cosine is sine, easy peasy. And then my limits are going to be 0 and pi. So let's set it up. We have 1/2 times sine of pi minus 1. Did I say 1/2? 1 pith? 1 pith of sine 0. So this is going to be easy. 1 over pi times sine pi is going to be 1 over pi times 0. And 1 over pi times sine 0 is going to be 0. So that's going to be 0 minus 0. Let me get my calculator. 0. The answer is 0, which should make sense because, you know, if you were to graph cosine, okay, from 0 to pi, you're going to get nothing for the average value because you're going to go from 1 to -1. And the average value of 1 to -1 is 1 plus -1 divided by 2, which is nothing. So it all makes sense in the end. Thanks for watching, like, and subscribe. On the given interval, find the x value where the function is equivalent to the average value on that interval. So we have a function, we have the interval. So let's come up with our average value function before we can even consider that. The average value function is 1 over b minus a, where you would be my a, you would be my b. Limits are a and b of f of x dx. Okay, so that's the formula that we use. Okay, so f of x is 3x plus 1. So I have 1 over 4 minus 1. Then we're going to multiply the integral from 1 to 4 of 3x plus 1 dx, like that. Okay, so you're a third. I can handle that. Let me see. The integral of 3x is going to be 3 halves x squared plus x. Limits are 4 and 1, but not in that order. All right, so let's scooch that over here where I'm going to need this space because this is not going to be that much fun. Well, it won't be that bad. Maybe. 1/3, 3 halves, 4 squared plus 4. That's the one guy. And then we're going to subtract 1/3, 3/2, 1 squared plus 1. Okay, so we're doing the whole integration thing. That's going to be 1/3 times 3/2. 4 squared is 16 plus 4 minus 1/3. 3/2, 1 plus 1. All right, I can do that. 1/3. So 3/2 of 16 is going to be 24. 24 plus 4 is 28, so that's not going to simplify nicely. That's great. Minus 1/3 of 3/2 times 1 is 3/2, plus 1 is going to be 5/2. Ugh. All right, so 28/3 minus 5/6. So let's turn 28/3 into, what would that be? 56/6 minus 5/6 is 51/6. Holy Christmas. All right, so I've got it. That's my average value. I need to find the x that gives us that. So I have 51/6 equals 3x plus 1. If I subtract 1, that's me subtracting 6 from 51, which is going to be 45/6. Like that, which does simplify. I'm looking at it. That does simplify. That's going to equal 3x. So why don't we simplify that? That's going to be, divide the top by 3 is going to be 15 over 2, right? Equals 3x. And if I divide everything by 3, or I guess I should have multiplied everything by 3. I don't know. That would be 5/2 equals x. 5/2 last time I checked is 2.5. I did not like that problem, not one bit. All those fractions, no thank you. I'll pass on the fractions. But we did it, and boy did we not have fun. Like and subscribe. Find the value or values of b such that the average value of the function y equals 2 plus 6x minus 3x squared on the interval 0b is equal to 3. All right, so here's our average value function, like that. Okay, we're going to integrate between 0 to b of 2 plus 6x minus 3x squared dx. And at the end of the day, we want that to equal 3. All right, so that's got to equal 3. We'll write that out at the end. All right, so you're going to be 1 over b. I can handle that. You're going to be 2x plus 3x squared minus x cubed. My limits are going to be 0 and b. All right, so let's set it up. We've got 1 over b times 2b, or not, plus 3b squared minus b cubed minus, oh, this is good, 1 over b, 2 times 0 plus 3 times 0 squared minus 0 cubed. So you will all go away. So this is what I'm going to be left with. All right, so let's move that over here. Okay, let's move that over here. That's going to be 1 over b, 2b, 3b squared minus b cubed. So after distributing 1 over b to everything, you become 2, 3 regular b minus b squared. Now I have to set that equal to 3. So let's do this. Let's move everything to the right side and reorganize everything. All right, so we get 0 is equal to b squared minus 3b. And if I subtract 2 from 3, I get 1. Like that. Normally I'd factor that out. I can't. So I'm going to have to use the quadratic formula, which is going to be, normally I'd say x equals, but it's going to be b equals, but there's already b's there. I don't like it. So b equals, if I were to call you invisible 1, a, invisible b, I'm going to keep it b because why not stay consistent? Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's going to give me negative 3 plus or minus the square root of negative 3 squared minus 4 times invisible 1 times regular 1 all over 2 times 1. So negative 3 plus or minus the square root. 9 minus 4 is 5 all over 2 times 1, which is 2. So I'm going to have 3 plus root 5 over 2, or also 3 minus root 5 over 2. So we're going to have 2 b's. So remember before where I said 2 b's or not? We did. Oh, it's all funny. It's all good. Please like and subscribe. A particle's velocity is given by, the velocity is 3t squared minus 5t plus 2. The function x of t represents the position of the particle along the x-axis. So we have the velocity, we need to find the position. We're going to integrate, baby, find the position of the particle after 4 seconds. Given the initial condition at 0 seconds, we're at 10 for the position. So let's integrate straight up there. So we're going to have the integral of v of t is going to give us our position function. All right. So we're going to integrate 3t squared minus 5t plus 2 dt. Okay, that is going to be t cubed minus 5 halves t squared plus 2t plus c. All right, so that is going to be our our position function. Now that arbitrary plus c has got to remain there because we have two parts here. Part A says, all right, well, let's get the initial condition 0, 10. So I have to find c, given the fact that I have t is 0 and I get 10. So we're going to set this equal to 10. That's going to equal 0 cubed minus 5 halves 0 squared plus 2 times 0 plus c. You go away, you go away, you go away. Okay, so in this case, 10 is c. Now that I know that, I can rewrite this equation here and say my position function, x of t, is going to be t cubed minus 5 halves t squared plus 2t plus c. Now I care about what happens at 4 seconds. So x of 4 is going to be 4 cubed minus 5 halves 4 squared plus 2 times 4 plus 10. I don't know why I put plus c there. It's plus 10. I just found out that it was 10. Why did I do that? Plus 10. Plus 10. Okay. You're 64 minus 5 halves, you're 16, you're 8, you're 10. 64 minus 40, yep, 40, plus, we'll just combine these, 18. 64 minus 40 is going to be, what is that, 24? Why did that take me so long? 24 plus 18 is going to be 42. And where are we? Where are we? Where are we? Seconds, do I have feet? Do I have feet? Do I have feet? I've got nothing. So 24 units or whatever. 42 units. 42 units. Okay? Cool. Now we got to do this again, and this next one's going to be a little bit more complicated because we're plugging in 1 to get negative 1. So negative 1 is going to equal that guy with 1 plugged in for t, 1 cubed minus 5 halves times 1 squared plus 2 times 1 plus c. So negative 1 is going to equal 1 minus 5 halves plus 2 plus c. Negative 1 is going to equal what is that? 3 minus 2, so that's 2.5. So 1/2 plus c. Subtract a half, and we're at -3/2. Ugh, plus c equals c. So now I'm going to use this equation, or this equation rather, but replace the c with -3/2. So that's my new function. This isn't going to be exciting at all. X of t is going to be t cubed minus 5 halves t squared plus 2t minus 3 halves. X of 3 is going to be 3 cubed minus 5/2, 3 squared plus 2 times 3 minus 3/2. 27 minus 5 halves times 9 plus 6 minus 3/2. Let's move that up here. Let's move that up here. Let's move that up here. 27 minus 45/2. 6 minus 1.5 is going to be 4.5. So let's turn that into 9/2. So minus, right? 4.5 is 9/2. 27 minus 54/2 is going to be 27 minus 27. Get out of here. No way. All right, so we didn't really move anywhere. We didn't go anywhere after all that. Or that's where our position is. Our position's at nothing. Oh, that's fun. All right, well, that took a while, but boy, did we have a great time doing it. A ball is thrown down off of a house with a velocity v of t equals -32t minus 8, where t is time in seconds and v is feet per second. The ball is 20 feet in the air at time t equals 1, which is the initial height of the ball. So in order for me to find the initial height of the ball, I need to integrate v of t dt, right? And that'll get me that height. So we'll say h of t, okay, for height over time. So let's integrate this, right? We're going to take the integral indefinite of -32t minus 8 dt. That's going to get me negative, what is that, 16t squared minus 8t, which looks about right because that's a typical gravity-looking formula right there. All right, plus c, we can't forget that. Now we're given this initial condition that when t equals 1, I get 20. So I have to find c by plugging in 1 for t and setting it equal to 20. So 20 is going to equal -16 times 1 squared minus 8 times 1 plus c. 20 is going to equal -16 times 1, which is -16, minus 8 plus c. 20 is going to equal -24 plus c, add 24, add 24, and you get 44 equals c. So the height formula is going to be h of t equals that guy, but replace the c with 44. So that should be h of t, not h of 4. Don't know why I put h of 4 there. So let's erase it. H of t is going to equal -16t squared minus 8t plus 44. Now, my job is to find the initial height of the ball, which means when time is 0. So h of 0 is -16 times 0 squared minus 8 times 0 plus 44. Adios, goodbye, and h of 0 is 44 feet in the air. And the answer is C. Mr. Anderson leaves for a trip at 2 p.m. and at 2 p.m. the time is t equals 0 and drives with a velocity of 50 minus 1/4 t miles per hour, where t is measured in hours. Find the integral from 0 to 3 of v of t dt. Okay, I can handle that. Very simple, very straightforward. Doesn't seem like a chapter 8 type problem, but I can handle it. The integral from 0 to 3 of 50 minus 1/4 t dt. So let's integrate that. 50 becomes 50t. U become minus 1/2 t squared, and my limits of integration are still going to be 0 and 3. Okay, so let's plug that in. 50 times 3 minus 1/2 3 squared minus 50 times 0 noish minus 1/2 times 0 noish squared. You will go away. How nice. You become 150 minus 1/2 of 9, which is going to be 150 minus 4.5. We'll leave it as decimals here because why not? 145.5. And that's going to be stuff that happens. That's going to be his distance traveled after, what, 3 hours? Or at 5 o'clock, this is where he is. So he is at 1.5 feet, miles, doesn't say, miles. Yeah. Pretty straightforward. The graph to the right shows the velocity of an object moving along the x-axis over a 5-second period. If the object started 2 meters to the right, where is the object after 3 seconds? So this is the velocity function. All right, and here it's asking us where stuff is, distance, and where stuff is. So what I really need to focus on is the derivative of the velocity. Okay, not the derivative, the integral of the velocity. Now, what that means for us here is if this is the velocity function and I don't have the actual function itself and I really don't feel like trying to find the piecewise function that matches that guy, what I can do is I could use the fact that, look, the integral is just the area under the curve. So let's use that information. If the object started 2 meters to the right, you're already at 2. Where is the object after 3 seconds? Well, we care about the integral from 0 to 3 of v of t dt. Now that means the area underneath the curve from 0 to 3. So the area here is going to be 1 block, 2 block, 3 block, 4. Easy. This is a triangle with base of 1 and height of 2. So 1/2 of base times height is going to be half of 1 times 1 times 2, which is half of 2, which is 1. So I get a full guy here. So you are the same as saying 2 plus 5, which is 7. So we are 7 units wherever that's supposed to be to the right. Okay, I'm assuming that we're still 2 meters to the right, so let's keep that 2 going on there. Where is the object after 5 seconds? Well, we're going to do the same thing. Now this, we just found out that this guy right here is 5 in the positive. Okay, everything down here is going to be negative. So if you were 1, that means this chunk right here is going to be -1, and this chunk right here is going to be -2. Okay, so 2 plus the integral from 0 to 5 of v of t dt is going to be 2 plus that +5 plus that -3. 2 plus 5 is 7, 5 plus -3 is 4. 4 is going to be my answer there. Now to find the total distance, okay, is not displacement. This was displacement. The total distance is the fact that if I were to drive forward 5 feet and back 3 feet, that's still 8 feet. So I have 2 that I started out with, plus the 5 that I drove forward, plus the absolute value of the -3 of me driving backwards is going to be 2 plus 5 plus 3, which is going to be 10. Okay, so this problem was very different, but I kind of liked it. It was fun. A particle's velocity is given by v of t equals 3t minus 10, where t is measured in seconds, v is measured in feet per second, and s of t represents the particle's position. So we are going to do something along these lines, ladies and gentlemen, and integrate v of t to get s of t, easy peasy. So if s of 0 is 5, what is the value of s of 4? So this is what we have to do. We have to integrate that guy right there. Shouldn't take too long. And I'm not even going to do that for part A. I'm just going to do that in general because we're going to need that to do part B as I'm looking ahead. So the integral of 3t minus 10 dt is going to equal 3/2 t squared minus 10t plus some arbitrary c. I have to leave that lingering. Now part A, I have to find out what C is because it's giving me this initial condition that when I have 0, I get 5. Okay, so I'm going to set it equal to 5 and say 3 halves times, let's replace t with 0, so 3 halves of 0 squared minus 10 times 0 plus c. Nice, c is 5. Now that's not me being done. That's just me saying now I have myself an integral, c is going to be 5. So if I have my position function, if s of t is going to equal 3 halves t squared minus 10t plus 5, I can easily find out what happens when I substitute in 4. So s of 4 is going to equal 3 halves 4 squared, a fun game, minus 10 times 4 plus 5. 3 halves of 16 minus 40 plus 5 is going to be, what is that going to be? It's going to be 24 minus 40 plus 5 is minus 35, and 24 minus 35 is negative 11. So I am, according to this problem right here, I am negative 11 feet backwards, okay, at 4 seconds, or 4 seconds, okay. Now that is part A. A is done. What is the value of s of 4? Dunzo. Now what I have to do is I have to do part B, which is asking for the net change. That's the same exact thing as displacement. Okay, so since I already found the integral, normally displacement would be found by integrating between 0 and 6 of that v of t function, right? But in this case, all I have to do is, since I found out what that is s of 6 minus s of 0. Okay, we found our s, we did the plus 5 thing, and so that's going to end up being s of 6 is going to be 3 halves 6 squared minus 10 times 6 plus 5 minus 3 halves of 0 squared, how nice, minus 10 times 0 plus 5. So you'll go away. That's going to be 3 halves of 36 minus 60 plus 5 minus 5. So you guys in time will go away. So 3 halves of 36, which I should be able to do right now, 18 times 3 is 48. 48 minus 60 is going to be negative 12. So at the end of the day, we are 12 feet behind where we started. I heard of putting a good foot forward, but 12 feet backwards? Well, that's no good. And it is in feet, isn't it? It is in feet. Thanks for watching. The rate of fuel consumption in gallons per minute recording during an airplane flight is given by a twice differentiable and strictly increasing function r of time t. This sounds like it's going to be a lot of fun. A table of selected values of r of t for the intervals 0 and 90 is shown below. So this is the rate, and it's the rate of fuel in gallons per minute. So at 0 time, you're burning 15 gallons per minute. At 20 minutes, you're burning 60, so on and so forth, so on and so forth. Using correct units, what does the integral from 0 to 90 of r of t dt represent in the context of this problem? Oh, that's not that bad. All right, so when you integrate a rate, you're going back to its original thing. So you're kind of getting rid of the per time part. So we're just dealing with gallons here. Really is what you're doing when you integrate. So between 0 and 90, we are finding how much fuel we're going to use for the first 90 minutes. So which one of these is going to give us that? The total fuel consumed in gallons during the airplane flight from 0 to 90 minutes sounds good to me. The average, no. The fuel consumption rate, no. The increase, no. The maximum, no. So it's the total fuel. You have to keep in mind that if you integrate a rate, you are finding the total amount used. And that's what we're doing here. This problem is a lot friendlier than it had to be. Water is pumped into a tank at a rate modeled by R of T liters per hour, where R is differentiable and decreasing from 0 to 8. Selected values of R of T are shown in this table right here. At time T equals 0, there's already 6,000 liters of water in the tank, so that's nice. What does the integral of R of T represent in this situation right here? Well, when you integrate a rate, you are looking for basically the original guy, which is liters of water. So without saying a ton, when I integrate that, what I'm finding is the amount of water pumped into the tank over its first 8 hours. So the amount of water pumped in the first 8 hours. Okay? Not too bad. Now this is not going to be fun. Estimate 0 to 8, the integral from 0 to 8, using left-Riemann sums. So since I'm not given a formula, I'm going to have to use left-Riemann sums. And so that's going to be me kind of drawing out a particular picture. Now let me draw that picture out right here. All right. Okay, so let's just say that we have 3K, 2K, 1K. All right, so 1K, 2K, 3K. I'm at 0 right here. I'm at 1. I'm at 3. I'm at 6. I'm at 8. Okay, at 1, I'm at 3K, so 3.5 right there. Now I'm using left Riemann sums, so that's why, by the way, this looks the way it looks, okay? So what else am I doing? At 3, I'm focusing on the fact that 1 is 28, so somewhere up here, that's going to look like that. At 6, I'm focusing on the fact that 3 is 23K, so somewhere up here. And at 8, I'm focusing on the fact that 6 is 1.7, so somewhere up here. Okay, so let's label all this stuff. Okay, let's label all this stuff. I have a length of 1, length of 2, length of 3, length of 2. Here I'm at, so 3,500 right here. Here I'm at 2,800. Here I am at 2,300, and here I'm at 1,700. So using left Riemann sums, what I'm going to do is I'm going to do 1 times 3,500, like that, plus 2 times 2,800, plus 3 times 2,300, plus 2 times 1,700. And of course everybody knows that that's 19,400. I didn't use a calculator by pausing my video. So that's what my estimate is. That is my estimate of the amount of water pumped into the first 8 hours. Now, based on this estimate, how many liters of water are in the tank after 8 hours? Well, I know that I started out with 6,000, and I know that I added roughly 1,900 or 19,400. Okay, adding those two guys together, I get 25,400 liters. Okay, so that's how you do that problem right there. Not the most fun problem in the world because no one likes Riemann sums, but hey, everybody loves Riemann. They just don't like his sums. Thanks for watching. Thanks for watching. Lucy is painting a fence at a rate of R of T equals 250 minus 5T square feet per hour, where T is the number of hours since she started painting. If the fence is 1,000 square feet, how long will it take her to finish painting the fence? Round your answer to the nearest minute. Ugh. So we have the rate, and the rate is square feet per hour. Okay, we need to integrate that to find out how long it takes to cover everything that it is. Not only that, okay, so we're going to integrate that. We know that this whole thing is going to equal out 1,000. So the integral of the rate is going to give me what is covered, knowing very well that it's got to equal 1,000. I don't have an initial condition, except that I do know it's 0, 0. I don't know if that's going to help me, but I'm just going to integrate with respect to 0 and t. Okay, and that'll, with it limits at 0 and t, capital T, and that should help me out. So integrating this guy on the left is going to be 250, not 200, but 250 t minus 5 over 2t squared with limits at 0 and t. That's got to equal 1,000. Okay, so doing this guy, I get 250 capital T minus 5 halves capital T squared minus 250 capital 0 minus 5 halves double capital zeros squared equals 1,000. You go away. So we end up with 250t minus 5 halves t squared equals 1,000. All right, so let's do this. Let's multiply everything by 2 to get rid of that. Let's multiply everything by negative 2 to get rid of that. So that'll be negative 500t plus 5t squared equals negative 2,000. Let's add 2,000 to both sides and rearrange things so we have 5t squared minus 500t plus 2,000 equals 0. I can rip out a 5. So I'm going to do that. 5t squared minus 100t plus 400 equals 0. Ugh. All right, I don't know if that's factorable. I don't think it is, so I'm going to have to use quadratic formula. T equals negative b plus or minus the square root of b squared minus 4 times a times b all over 2a. Invisible 1 is my a, negative 100 is my b, and 400 is my c. So t is going to equal negative 100 plus or minus the square root of negative 100 squared minus 4 times invisible 1 times 400 all over 2 times 1. So I'm not going to pretend like I know how to do this. I'm just jumping straight to a calculator and find out that that square root ended up being 91.96 all over 2. So we have two options here. Okay, 100 plus 91.96 all over 2. That's supposed to be a 2. And 100 minus 91.96 all over 2. Okay. Now, here's what we have to keep in mind. Okay, that minus represents a time. That's not going to make sense. So we're going to have 191.96 all over 2. Okay, that is going to be, I don't know, 95.83 according to the internet. 95.83. Now that is hours. To convert that to minutes, you multiply 60. Multiplying that to 60 is going to get you roughly 5,750 minutes according to the internet once again. So not the prettiest problem in the world. Not the prettiest problem in the world, but we did it and we had so much fun. Find the area of the region bounded by the following graphs. You have y equals 1 over x squared. You have y equals 0, aka the x-axis, and x equals 2 and x equals 6. Basically what we're looking at, okay, is if I were to draw this guy out on a coordinate plane, okay, we are looking at y equals 1 over x squared is going to look like this up here and then reappear down there and look like that. Okay, you have y equals 0, which is just the x-axis, just the formula for the x-axis, nothing fancy. Now, by putting this at x equals 2 and x equals 6, we care about the area between 2 and 6, whatever that might look like. So we're looking at something that looks a little something like that. So what you're going to do is you're going to label these two graphs f of x and g of x. Now, if you're drawing this out, try to label the upper graph f of x and the lower graph g of x so that when you do what we're about to do, you'll get a positive area. If for some reason you do this and you get a negative area, you're not wrong. Just make it positive and you'll be just fine. All right, but the formula that we're going to use is going to be the integral from whatever a to whatever b, so in our case 2 to 6, of f of x minus g of x dx. And this is us finding the area between the two curves. So setting this up over here, I decided to call f of x 1 over x squared. So I'm going to have 1 over x squared minus g of x, which is a big fat nothing. Now my limits of integration are going to be 2 and 6 because that's the x values that were given here, dx. Okay, so you do a little bit of integrating. I mean, maybe not yet. Maybe if I wanted to clean this up, I would say between 2 and 6 of 1 over x squared dx. And I don't like the way that looks, so between 2 and 6 of x to the negative 2 dx. Okay, and then that becomes, what is that, negative 1 over 1, so negative x to the negative 2 plus 1, which is negative 1. Limits are 2 and 6. Okay, so the integral of x to the negative 2 is negative x to the negative 1. Let's clean that up a little bit, make that look like negative 1 over x with the limits at 2 and 6. Okay, now we'll plug in our limits of integration and do a little bit of mathy math. Negative 1 over 6 minus negative 1 over 2. So I'll keep that negative 1 over 6, negative 1 over 6. We'll make that double negative a positive. We'll make you 3 over 6, giving us, what is that, 2 over 6, giving us 1/3. Which is going to be C. So that's how you do that problem. Isn't that fun? So much fun. Find the area of the region bounded by the following graphs. We have x squared and we have y equals x to the third. So we kind of know what these guys look like. All right, x squared is just a little parabola. So if I were to graph this over here, all right, and you'll see what we're going to focus on. X squared is a parabola, so I'll make you green. Look something like this. And then x to the third since it's just x to the third, it's going to kind of look like this. All right. So maybe I'll scooch you down just a bit. I'll scooch you up just a bit, and everybody's happy. So what we're trying to find is that little area right in here, that little sliver right there. So this is what we need to do. The formula for finding an area between two graphs is you take the one function, right, and you subtract the other function. What we also need to do is we need to find our limits of integration, which we don't know yet. I need to find out where these guys intersect. So I need to find out what you are and what you are. So if we need to find out where they intersect, we take these guys and set them equal to each other. So x squared equals x to the third. So why don't I subtract x squared from both sides? So we get 0 equals x cubed minus x squared. Let's pull out an x squared, so 0 equals x squared, leaving us with x minus 1. And using the zero product property, we get zeros at 0, so x equals 0, and positive 1. So my limits of integration are going to be a, b, 0, and 1. So you're 0, you're 1. Okay, so now I have everything I need. Now, according to the graph that I drew, you really want to have the upper graph be your f of x. So it looks like the x squared is going to be my f of x, and x cubed is going to be my g of x. If you have this backwards, then what's going to happen is you're going to get a negative area. You're not wrong, just make it positive and everything is fine. You can't have negative area in a real world sense if we're talking about that. So you just make it positive, no big deal. That's going to happen from time to time. But the integral that we're going to set up is the integral from 0 to 1 of x squared minus x cubed dx. Okay, so integrating that is going to give us 1/3 x to the third minus 1/4 x to the fourth with limits at 0 and 1. So we plug stuff in, 1/3, 1 cubed, minus 1/4, 1 to the fourth, right? Minus 1/3, 0 cubed, easy. Minus 1/4, 0 to the fourth, easy. The entire right side, the entire right bracket is just going to become 0, make it go away. This becomes 1/3 times 1, so 1/3, minus 1/4 times 1, so 1/4. Okay, let's make these over 12 so we can combine fractions. So you're going to be 4 over 12 minus 3 over 12, which is 1 over 12. So that little tiny sliver isn't a whole lot, but that sliver accounts for 1/12 square units. And that is our answer, baby. Find the area of the region bounded by the following graphs. We have y equals x and y equals x squared minus 6. So if I were to draw just a little picture, okay, of what's going on here, y equals x squared minus 6, let's actually move u up because that's going to be probably the more important part. Y equals x squared minus 6 is just a regular old parabola shifted down 6 units, something like that. Okay, that's what u is. Y equals x is going to be a linear equation going through that. Oh boy, good job drawing a line by me. No one will ever know. Now, the function for finding the area bound by two graphs is going to be the integral with limits of integration a and b of f of x minus g of x dx. A and b are where these two lines intersect. So I have to find out where these two lines intersect. And then what I'm going to do is I'm going to take the upper graph, which appears to be the linear equation, and subtract out the lower graph, which appears to be the parabola. But first, like I said, we have to find out where they intersect. So I'm going to set these guys equal to each other. I'm going to have x equals x squared minus 6. Let's subtract x from both sides. 0 equals x squared minus x minus 6. Factor that out, x minus 3, x plus 2, and my zeros are going to be at positive 3 and negative 2. So those are going to be my limits of integration. I'll make the smaller one a, the larger one b, like so. And now we have enough ammunition to plug stuff in. So I have the integral from negative 2 to 3 of f of x, which we're calling the linear equation, x minus g of x, which is x cubed minus 6. Now, if you're like, what if I have that backwards? Then you're going to get the same exact number, but it's going to be negative, and you just have to realize, oh, since I got it backwards, the answer is going to be the opposite, so it's going to be a positive whatever. So if my answer is negative 50, the actual answer is positive 50. So let's go ahead and do this. Let's rewrite that out after distributing the negatives. So negative 2 and 3, x minus x squared plus 6 dx. And let's integrate that. So you have 1/2 x squared minus 1/3 x cubed plus 6x with limits at negative 2 and 3. Ugh. This is not going to be fun. All right. That's my song. 1/2 3 squared minus 1/3 3 cubed plus 6 times 3 minus 1/2 negative 2 squared minus 1/3 negative 2 cubed plus 6 times negative 2. We're going to use all this space because I have a feeling we're going to need it. All right, we've got 1/2 times 9 minus 1/3 times 27 plus 18 minus 1/2 times 4 minus 1/3 times negative 8 plus or minus 12. not plus or minus, just minus. It's not a quadratic formula. Oh, we have fun when we screw up. We got 9 over 2. We've got negative 1/3 of 27 is negative 9 plus 18 minus, we've got half of 4, which is 2. Negative 1/3 of negative 8 is positive 8/3 gross minus 12. That is going to be let's kill birds with two stones. I'm leaving it. I'm not editing anything. A negative 9 plus 18 is going to be 9. So let's make that 18 over 2. Okay. What is that? Negative 10 plus 8 over 3. So let's make 8 over 3, 8 over 3, and negative 10 is going to be minus 30 over 3. Okay? See what I did there? That is going to be 27 over 2 minus negative 22 over 3, which is going to be, let me see, we got a double negative here, so I want to multiply the top and the bottom of this one by 3, so 27 times 3 is 81. So we got 81 over 6 plus 44 over 6, which ends up being 125 over 6. Does that simplify? No. So that's our guy. Whew. So yeah, that's what this whole region is. That whole region is whatever 125 over 6 is. So not pretty, but neither's your mama. Thanks for watching. Bye. Find the area bounded by the curves y equals 2 sine x, y equals 1, and x equals pi over 6, and x equals 5 pi over 6. All right, so simply put, 2 sine x is going to look something like this. Something like that. Okay, where it goes up to 2. All right, easy peasy. Now, if it's going to also be y equals 1, that's going to be a line that looks something like that. Okay, that's y equals 1. It just so happens that I know what these guys are because I created the problem. You are pi over 6, you are 5 pi over 6. So we're finding the area in between those two guys, which means we're finding that. Now, the formula for finding the area between two curves is you have your limits of integration, right? You're going to integrate f of x minus g of x dx. Now, which is which? Try to make the upper part your f of x and try to make your lower part g of x. And the reason why we do this is because this will give us a negative or a positive area. If for some reason we have it flip-flopped, it's going to give us a negative area, same number, no problem. We just have to make it positive. So now that I have everything that I need, I can set up my integral, which is going to be the integral from pi over 6 to 5 pi over 6. And we're going to do 2 sine x minus 1. So 2, that's not a sine. That is a line for the x. I don't want that. 2 sine x minus 1 dx. Okay, we can just integrate immediately. So the integral of sine is negative cosine. So 2 sine x is negative cos x. Negative 2 cos x is a close one. And then the integral of negative 1 is minus x. My limits are still going to be pi over 6 and 5 pi over 6. So now we do a little pluggarooski. We plug in negative 2 cosine 5 pi over 6 minus 5 pi over 6. And we're going to subtract out negative 2 cosine 1 pi over 6 minus pi over 6, that 1 pi over 6. So negative 2 times cosine of 5 pi over 6. The cosine of 5 pi over 6 is negative root 3 over 2 minus 5 pi over 6 minus negative 2. The cosine of pi over 6 is positive root 3 over 2. And then we have minus pi over 6. Okay, so a couple things happen. U and U cross out, negatives cross out, U and U cross out. So that leaves us with root 3 minus 5 pi over 6 minus negative root 3 minus regular pi over 6. Okay, let's distribute that negative. And so that leaves us with root 3 minus 5 pi over 6 plus root 3 plus pi over 6. Combine like terms, a root 3 plus a root 3 is 2 of them, 2 root 3's. Negative 5 pi over 6 plus pi over 6 is negative 4 pi over 6. And that guy will simplify out to 2 root 3 minus 2 pi over 3, which is going to be A. Isn't that neat? Find the area of the region bounded by the following curves. Set up your integrals with respect to y. Oh, so we're doing something different now. Same idea though. What you're going to do is you're going to find your limits of integration, find them, and then you're going to subtract f of y minus g of y, because they're two different ones. Okay, and then we're going to integrate that with respect to dy. So these are already solved for x. That's good. What I need to do is find out where these guys intersect, and that'll give me the limit of integration. So we're just going to set negative 3 equal to y squared minus 4, add 4, add 4, and so 1 is going to equal y squared. Square rooting everything is going to give us limits of integration at positive 1 and negative 1. So positive 1 is going to be a, negative 1 is going to be b, except I have that backwards. So let's set this up. The integral from negative 1 to 1. Now, in my last 4 videos, if you watch them, I was hyper-focused on making sure which one was above and which one was below. I'm not going to do that here. I'm just going to do it. And if I get a negative area, then I get a negative area, and I just have to flip it upside down in the end anyway. So I'm going to take a wild guess and say, I don't know, negative 3 is going to be my upper one, and then I'm going to subtract y squared minus 4 dy. So let's simplify that. That's negative 1, 1. Negative 3 minus y squared plus 4 dy. Let's scooch that over here where I have a little bit more space. Negative 1 to 1. Negative 3 and 4 make 1, so I have negative y squared plus 1 dy. Integrating negative y squared is going to be negative 1/3 y cubed, and integrating 1 is going to be just y, and my limits are still going to be negative 1 and 1. So now we plug our stuff in. Negative 1/3 times 1 cubed plus 1 minus negative 1/3 times negative 1 cubed plus negative 1. Now it's just a matter of doing some simplification. Negative 1 times 1 cubed is going to be negative 1/3 rather, times 1 cubed is going to be negative 1/3. Okay, 1 cubed is 1, plus 1, minus negative 1/3 times negative 1/3 cubed is going to be negative 1/3 times negative 1, which is positive 1/3. And then I'm going to have minus 1, like so. U become 2/3 minus U become negative 2/3. So the double negative makes it a positive, and the whole thing becomes 4/3. So that is how you do it. So I chose correctly by assuming that negative 3 was the quote-unquote f of y higher one. But yeah, that's how you do it, and boy did we have fun. Find the area of the region bounded by the following curves. Set up your integrals with respect to y, which means these guys have to be solved for x. Well, you're solved for x, you're not. What I'll do is I'll do two things at the same time. I'll add x and subtract y, and by doing that, you become x equals 2 minus y. No harm, no foul. Okay, then we also have y equals 0. That's going to serve as a limit of integration. Now, what we also don't have is the other limit of integration. So the way I'm going to find my limits of integration is I'm going to set these guys equal to each other. Okay, I'm going to say y equals 2 minus y. If I add 2 to both, if I add y to both sides, that becomes 2y equals 2. Divide both sides by 2, and y equals 1. So my limits of integration are going to be 0 and 1. So we set up our integral. All right, and now the general equation for this is from a to b, the integral from limits of integration a to b of f of y minus g of y. Now normally I hyper-focus on which one of these is the higher graph, but I'm not going to do that here. If I end up with a negative area, I'm just going to make sure I turn it positive. We'll see what happens. I'm not scared of anything. But what I do have is I have the fact that my limits are now 0 and 1. That was a close one. 0 and 1. I'll call f of y, I don't know, x. Not x, y. Minus 2 minus y, close it, dy. Let's simplify that a little bit. Okay, y minus 2 plus y dy is going to be 2y minus 2 dy. Now let's integrate that. The integral of 2y is just y squared, and the integral of negative 2 is negative 2y. Your limits of integration are still 0 and 1. So let's plug stuff in. We get 1 squared minus 2 times 1, close it, minus 0 squared, how nice, minus 2 times 0. That gives us here 1 minus 2 minus nothing. 1 minus 2 is negative 1. Now again, I was worried that this would happen. I guessed wrong by choosing y as f of y. No big deal. All we have to do is flip-flop it, and we get 1. And so the answer is A, 1 square unit. Baby. Find the area of the region bounded by the following curves. Set up your integrals with respect to y, which means we have to have these as x equals something. Well, Chekaruski, you're already good. You ain't. So in order to make that x equals something, I have y equals the square root of x. No big deal. Let's just square both sides. And that gets us x equals y squared. Now, whenever we're finding the area between two curves, we use the formula, the limits of integration from f of y minus f or g of y dy. I don't know my limits of integration. But the way I find my limits of integration is I take that guy and set it equal to each other. So let's set it up this way. Y squared equals y plus 12. Let's subtract y, subtract 12, subtract y, subtract 12. And that gets us, you are gone, y squared minus y minus 12 equals nerfing. Now this does factor out to y minus 4, y plus 3. Equals nothing, and that gives me y values at 4 and negative 3. Now when I set up my integral, I'm not going to go too crazy as to figuring out what f of y is and what g of y is, because what's going to happen is if I get a positive area, I'm good, and if I don't, I just make it positive and I'm still good. So I'm going just to do from negative 3 to 4 of y cubed, so this guy right here, minus y plus 12. So we're going to set it up that way, dy. All right, distribute that negative. We have the integral of y squared minus y minus 12. And now I can integrate. And that will be integrate when I do it. Okay, negative 3 to 4. Nope, I'm not doing that because I'm now integrating. See, I got hung up on my own joke. I screwed up. You become 1/3 y cubed. you become negative 1/2 y squared, and you become minus 12y. Okay, limits are at negative 3 and 4. Now it's just a messy math problem. All right, so 1/3 4 cubed minus 1/2 4 squared minus 12 4 minus 1/3 negative 3 cubed minus 1/2 negative 3 squared minus 12 times negative 3. All right, 1/3 times 64 minus 1/2 times 16 minus 48 minus 1/3 of negative 27 minus 1/2 of 9 plus 36. Ugh. 64 over 3 minus half, so minus 8 minus 48 minus 1/3 of negative 27 is negative 9 minus 9 over 2 plus 36. So let's just keep going. We've got 64 over 3 minus 56 minus negative 9, that's 27 minus 9 over 2. So let's move this up here. Do I need to? Do I need to? I kind of do. Let's move this up here where I have a little bit more space. You are going to become 64 thirds minus 168 thirds minus 42 halves minus 9 halves. Okay, 64 minus 168 is negative 104 thirds. Does that simplify? 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 No, it does not. Minus 45 halves. All right, so let's make this over 6, and then we're almost home. We're almost home. So if I multiply the top and the bottom by 2, I get negative 208 over 6. Minus, if I multiply the top and the bottom by 3, 135 over 6. And you're going to be a negative 343 over 6, which means we chose wrong. It's actually positive. So we'll just get rid of that because we are out of room. Holy crap. I did not like that at all. And I hope we did it right. And if I didn't, just tell me in the comments. You guys do that anyway, so I hope it helps. All right, so this be section 8.6, and this be the third section that we're talking about, area between curves. So how is this any different from the last two? Well, in the last two, we would mainly focus on here's a curve and here's a curve, and let's find the area between the two. Now we're looking at areas where we have maybe several intersections going on, and we have to take that into account. What this is going to look like is a cubic. It looks a little something like this. What this is going to look like is a parabola looks a little something like this. And when stuff like that happens, we notice, oh, wait a minute, there's two areas, that we have to find out. And so we're going to label you an A, we're going to label you a B, and we're going to label you a C. And what we're going to have to do is we're going to have to find the integral from A to B of the one, and then the integral from B to C of the other. And what could potentially happen is, yeah, it's going to be the same formula every time, but we have to keep in mind that we're doing like the absolute values. So maybe if we do it the exact same way each time, we'll get a positive area for one and a negative area for the other. But we have to keep in mind that we're talking about the areas in between curves, not above or below the x-axis. So this is going to be our process here. So problem one is find the x values of the points of intersection and label them from smallest to largest A, B to C. So we're going to walk through this process step by step. The way you find the areas of intersection or the points of intersection is you set the two equations equal to each other. 2x cubed minus x squared minus 7x equals x squared plus 5x. Okay. Let's subtract x squared, subtract x squared. Let's subtract 5x, subtract 5x. You go away, and you're left with 2x cubed minus 2x squared minus 12x equals that. We can factor out a 2 and an x, and that leaves us with 2x times x squared minus x minus 6. Set that equal to 0. And we have 2x, factor that out to x minus 3, x plus 2. So using the zero product property, our magic numbers are going to be 2x equals 0 gives us a 0, x minus 3 equals 0 gives us a positive 3, and x plus 2 equals 0 gives us a negative 2. So from least to greatest, we've got negative 2, 0, and 3. Set up the integrals for the area between the curves. All right, so what I'm going to do is I'm going to set up from A to B would be from negative 2 to 0, and we just take one minus the other. Now, if my picture is accurate, in this case, the upper curve is going to be the cubic. Again, not that it matters. If for some reason I were to do u minus u, I'd get a negative and I'd just make it positive anyway. But I'm going to try to be consistent. And so this guy is going to be 2x cubed minus x squared minus 7x. Minus that whole guy right there, x squared plus 5x, close it, dx. And then on top of that, we're going to add the next integral, which is going to be us integrating from 0 to 3, and if this picture is accurate, we've got the parabola on top this time. So we're going to do x squared plus 5x minus parentheses 2x cubed minus x squared minus 7x, close it, bracket it, dx. Now it looks like for this problem all we need to worry about is just the setup and not actually doing the problem. So we're not going to do the problem because I don't have all the space in the world, and I'm going to have like other videos where I actually do the problem. So we're going to leave this like that. But yeah, this is what you would do. And if for some reason I set this up incorrectly and I got negative areas for either of them, make them positive. And when you're done, you add them both up and you get your area between those curves. Hope this helps. Find the total area bounded by the curves y equals negative 1/2 x cubed plus 2x squared and y equals 4x minus x squared. What we're looking at is a negative cubic, so it's going to look something like this. And what we're also looking at here is an upside down parabola. It's going to look something like this. Now, when we do problems like this, and keep in mind, my picture is probably completely inaccurate, but that's all right. When we do problems like this, we're not looking just for an area between the curves. What's going to happen is we're going to have two areas. So we're going to have to do two separate integrals once we find our points of intersection, two separate integrals, and hopefully get positive answers for both. If we don't, make it positive, no big deal, and then just add them up. So what I need to do is I need to find out what my points of intersection are. And the way that I do that is by setting these guys equal to each other and solving for x. So we have negative 1/2 x cubed plus 2x squared equals y equals 4x minus x squared. Now, this is just going to be a gross mess. And what I'm going to do to start off is I'm going to multiply everything by negative 2. Because I kind of know what's going to happen if my job is to solve. I'm going to see a lot of factoring, and I don't want to deal with the negative 1/2. So if I multiply both sides by negative 2, that makes you positive x cubed minus 4x squared. That's going to be minus 8 plus 2x squared. Now let's move everything to the left. Move everything to the left. Let's add 8. Add 8. Let's minus 2x squared. Minus 2x squared. That goes away, and you're left with just 0 on the right. X cubed minus 6x squared plus 8. X. Oh my gosh, why did I not notice that? Plus 8x. Sorry, everybody. Ooh, I'm not going back and editing. Leave it alone. What can I do? Well, I can factor out an x. And when I factor out an x, that leaves me with x squared minus 6x minus plus 8 equals 0. That factors out to x minus 4 minus 2. So my magic numbers, and therefore my points of intersection, are going to be 0, 4, and 2. So 0, 2, and 4 in that order. All right, now I'm going to set up my integrals. Okay, and I'm going to do integral, I'm just going to set them up, I'm going to write everything out. Integral number 1 is going to be from 0 to 2, and according to my rough draft, I'm hoping that the parabola is the one on top and the cubic is the one on the bottom. If I'm wrong, then nothing major is going to happen. I'm just going to have myself a negative area, and I need to make it positive. No big deal. So let's do the parabola. So 4x minus x squared minus negative 1/2 x cubed plus 2x squared dx. So let's set that up that way. The other one is going to be the integral from 2 to 4 of, let's go the opposite way. Let's put the cubic first. So we've got negative 1/2 x cubed plus 2x squared minus parentheses 4x minus x squared, close it, dx, donezo. All right, now we integrate each one. Fortunately, and you know it would have been nice if I just kept them the same. It's too late. Let's just do the one on the left first. Let's do one on the left first. First thing we're going to do is distribute that negative. We're not even going to integrate yet. 4x minus x squared plus 1/2 x cubed minus 2x squared dx. All right, we can combine like terms here. So from 0 to 2 of 4x, u and u combine to make negative 3x squared plus 1/2 x cubed dx. All right, I had to stop the video and restart because real life happened. But here I am. I'm at this point right here where I have to integrate u. And integrating from 0 to 2 is going to leave me with 2x squared. What is that? Minus, just an x cubed plus 1/4. So 1/8 x to the 4th limits at 0 and 2. Now this is going to be kind of nice because the first one, I mean, the math is not going to be super bad like the movie. Remember that movie? I have more space over here, so I'm just going to scooch this over here. I have 4 times, nope, I'm looking at the wrong thing. 2 times, this video is not starting out well. 2 squared minus 2 cubed. That's supposed to be a 3 plus 1/8 2 to the 4th. Close it. Minus, I'll just get 0 because if I plug in 0, I'll get 0. So we'll leave that as that. Okay, let's make life easy. U will become 2 squared times 2 is going to be 8. Minus, oh, no way, 2 to the 3rd, which is 8. Oh, how about that? Plus 1/8 times 16. So we're just going to get 2. Look at that. All right, so you become 2. So this little chunk right here is going to be 2. Now let's do this guy. A lot of similarities going on. You could distribute that negative, so you become from 2 to 4 of whatever, x cubed plus 2x squared minus 4x plus x squared, close it, dx it. You become negative 1/2 x cubed. These guys combine to make plus 3x squared minus 4x, close it, dx it. And now when I integrate, I get a lot of similarities over here. This becomes negative 1/8 x to the fourth plus x cubed minus 2x squared, limits at 0 and 2. Nope, limits at 2 and 4. Let's get the smaller version of the eraser. There we go. Look at me being smart and learning from my mistakes. All right. So this ain't going to be pretty. I got negative 1/8 4 to the fourth plus 4 cubed minus 2 times 4 squared, close it, minus it. And then I already kind of know what's going to happen here. But I'm not going to do it. I'm not going to do it that way. Negative 1/8, 2 to the fourth plus 2 cubed minus 2 squared, close it. All right. Let me see. We are going to end up with 4 to the fourth is 256. And then negative 1/8 of that is negative 32. Okay, plus 64. 4 squared is 16 times negative. Oh, no way. No flippin' way. Nice. You just go away. How about that? Minus negative. So 2 to the fourth power is 16. So negative 1/8 of that is negative 2 plus 8. 2 squared is 4, but minus 8. So you get negative negative 2, which is also 2. So that guy became 2. That guy became 2. Last time I checked, 2 plus 2 is 4. Thanks for watching. Find the total area bounded by the curves y equals sine x and y equals 1 on the interval 0 to pi. So let's draw out what sine x normally looks like. Find the total area bounded by the curves y equals sine x and y equals 1 on the interval 0 to pi. This is me getting ready to draw out sine x. Looks like this. And it stops there at 2 pi. Peaks out at 1. So I care about this stuff going on right here. So I care about the area here from 0 to whatever u is, and from whatever u is to 2 pi. Okay, so I need to find what that guy is right there. Well, how do I find out what that guy is right there? Well, we set sine x equal to 1. To get x all by itself, if you're wondering, why all that space? So I can do this, baby. So I can inverse sine 1. And as you know from pre-calculus, the inverse sine of 1 is pi over 2. Okay, right there at 90 degrees, pi over 2. So you are my limit of integration for one of them and my limit of integration for the other. All right. Now I'm going to run into a fun little happy accident, but I'm going to pretend like that won't happen. I'm going to set up two integrals, and in both cases, y equals 1 appears on top. So one integral is going to be from 0 to pi over 2 of 1 minus sine x dx plus pi over 2 to 2 pi of 1 minus sine x dx. And at this point, you should realize, well, wait a minute. It's the same guy. Why not combine the two integrals into one whole integral and do from 0 to 2 pi of 1 minus sine x? Well, that's exactly what we're going to do. And the reason why that happens is because there's no upside down stuff going on. There's no upside down thing that I have to worry about. In both of these cases, y equals 1 is the top thing. There just happens to be a little sliver in between where it stops. And you have no area because the two lines intersect. So we're not going to lose sleep over that. The integral of 1 is x. The integral of sine x is cos x, so negative cos x is positive cos x. And my limits are 0 and 2 pi. So once I set this up, I get 2 pi plus cos 2 pi minus 0 plus cos 0. 2 pi is 2 pi. Cos 2 pi is going to be 1, so plus 1, minus 0 is 0, so get rid of it. Cos 0 is also 1. So this gets us 2 pi plus 1 minus 1, which is 2 pi. And that's how we do it. Consider the region bounded by the curves y equals x squared and y equals 4 in the first quadrant. Find the volume of the solid formed when the region is revolved around the x-axis using square cross sections. Ugh, picture time. Picture time. All right, so we're looking at y equals x squared. Okay, and we're looking at y equals 4. I'm going to be very bad at this. If I'm going to try to draw square cross sections, it's going to look something like that. Okay, squares going to look something like that, and then they get smaller, and then they get smaller, and stuff like that. Okay, now these are squares, and what we're looking at is whatever the height is between these two curves is also going to be the length. So if we're looking at 4 and x squared, the length of each side is going to be 4 minus whatever x squared is at the moment. So that's the thing that I need to look at first, is that the side length is going to be 4 minus x squared. Now, I care about the areas of these squares, because what I'm going to do is integrate the area, and by integrating the area we get volume. So if the side of a square is 4 minus x squared, then the area of a squared is the side squared. So the area, okay, a of x I guess we can call it, is going to be 4 minus x squared squared. And so by integrating the area, okay, we get ourselves volume. All right, now what I need to do is, it's not good enough for me to just integrate. I don't have any limits yet. I don't have limits of integration or anything like that. So I know you start at 0, but what are you going to be? Okay, what are you going to be? So we set these guys equal to each other. X squared equals 4. We don't lose sleep because I know that all I have to do is square root both sides. Okay, don't forget your plus or minus, and you get plus or minus 2. And then you remember that, oh yeah, we're only focusing on the first quadrant, so my limit is going to be 2. So you are going to be from 0 to 2. So let's set this equation up. Let's set this integral up. The integral from 0 to 2 of my area is 4 minus x squared squared dx. All right. Now, before we do anything, let's FOIL that out. Okay, that's a perfect square trinomial. So you're going to be 16 minus 8x squared plus x to the 4th dx. Now I can integrate. Okay, 16's integral is going to be 16x. The integral of negative 8x squared is negative 8/3 x cubed. And plus x to the 4th is going to be plus a 5th x to the 5th. My limits are 0 to 2. All right, so we set up our integral again. Well, not set up our integral, we set up our math problem. So we get 16 times 2 minus 8/3 times 2 cubed plus 1/5 times 2 to the 5th minus. If I plug in 0 to all three of you, you become nothing. So let's not overcomplicate things, shall we? Let's not. We're at this stage, we're this far into calculus, we don't need to overcomplicate things. You become 32. 2 to the 3rd power is 8. 8 times 8 is 64, so minus 64 over 3. 2 to the 5th is 32, so 32 over 5 is 32 over 5. Ugh. So I have 3 fractions in here. Common denominator is going to be 15. So multiplying 32 by 15 is going to get you 480 over 15. Multiplying u by 5 is going to be 320 over 15. And multiplying u by 3 is 96 over 15. $480 minus 320, 160, no, 140, 140 plus 90, no, it is 160. 160 plus 96 is 256. All over 15 is going to be u. Oh, boy, is that a gross problem. Didn't like that at all. The bounded region shown represents the base of a solid. Find the volume of the solid based on the given cross-section. Set up the integrals and evaluate. All right, so we're doing a cross-section of a square, and we're doing this perpendicular to the x-axis. So this is what we need to do, okay? Here are my boundaries. 0, I don't know. We've got y equals 2. We've got the cube root of x. All right, so by doing cross-sections of squares, we are creating a bunch of squares, right, all throughout this whole thing. And what we're going to do is we care about finding the area of these squares. Oh, that's such a bad picture. We're finding the area of these squares so that we can integrate that to find our volume. All right, now what I have to focus on is what are the side lengths of each squares? Well, if this top equation is 2 and the bottom equation is root x, then each side length is going to be 2 minus root x. And so if each side length is 2 minus root x, then to find the area of a square, we square the sides. So the area is going to be, a of x we'll call it, is going to be 2 minus root x squared. Okay, so what I need to do now is I need to find out what that limit is right there. The way that I can find out what that limit is right there is I can take my two equations down here and set them equal to each other. The square root of x equals 2. In order to get root x all by itself, I'm going to square it. X equals 4, and these guys intersect at 4. So the integral that I'm going to set up is going to be the integral from 0 right here to 4 of 2 minus the square root of x squared dx. Now, before I even consider integrating, I want to FOIL that out. I want to use a perfect square trinomial and clean that up. So that's going to look like 4 minus 4 root x plus x. Oh, this is going to be terrible. This is going to be terrible. This is going to be terrible. This is going to be so bad. Let's rewrite this out. Between 0 and 4. 4 minus 4x to the 1/2 plus x dx, and wish me luck. All right, so breathe in, breathe out. We have the integral of 4, which is 4x. Okay. We have the integral of this guy, which is going to be 4 over 3/2 x to the 3/2 plus x squared. Nope, 1/2 x squared with limits at 0 and 4. So let's clean this up a little bit more. 4x. This is going to be, if I flip this and multiply, this is going to be 8 over 3, so 8/3, so minus 8/3 x to the 3/2 plus 1/2 x squared. My limits are, squared's in the wrong spot. My limits are going to still be 0 and 4. Now the nice thing about this guy is, I guess, if there's a positive anywhere, here's a light at the end of the tunnel. Okay, when I plug stuff in, I'm going to have 4 times 4, no big deal. Okay, no big deal. Minus 8/3 times 4 to the 3/2, that's very unpleasant, plus 1/2 4 squared. If I were to do the minus and then do the same thing and plug in 0, it's all going to become 0. So we'll just say minus 0 and save some time. Okay, u becomes 16 minus 8/3. If I square 4, I get 16. And the cube root of 16 is going to be 2 root 2. No, it's not. 2 cube root of 2. Yeah, there's nothing I can do about that. Oh, no, I take it back. I'm cubing 4, which is 64. And then the square root of 64 is 8, so that's not that bad. I apologize. Plus 1 half of 4 squared is going to be 1 half of 8. Or 16, which is 8. So you become 16 minus 64 over 3 plus 8, which is going to be 24 plus 64 over 3. Multiply the top and the bottom by 3, giving you 72 thirds plus 64 thirds. And that's going to end up being 156 thirds. Gross. So definitely not a pretty problem at all. Not by any stretch of the imagination, but we did it. All right, this one's going to be very unpleasant. The x-axis in the graph of y equals the square root of 1 minus x squared. Each cross-section perpendicular to the x-axis is a rectangle whose height is 10 times the width. So basically what we're doing here is we're trying to find the area between these two curves. So you're looking at a rectangle, right? Looks like that. Looks awful. Let me scoot you over to make that maybe a better representation of a rectangle. Look at that. Look at that. Okay, and so what we're kind of looking at is, all right, what we're told is the width of this rectangle is going to be, it's a rectangle. So you have a rectangle, the width is going to be the square root of 1 minus x squared. The height of it is going to be 10 times that. 1 minus x squared, right, times 10. Now, in order to find an area, you multiply the length and the width. So the area formula is going to be 10 times the square root of 1 minus x squared times the square root of 1 minus x squared. Now, this makes life very convenient because that times itself makes the square roots go away. So you're left with 1 minus x squared. So the area formula ends up being 10 times 1 minus 10 x squared. So what I'm going to do is I'm going to integrate this guy. I'm going to integrate 10 minus 10x squared dx. Issue number one is I don't know my limits yet. But what I do know is this guy is set equal to the x-axis. So I'm going to do 0 equals the square root of 1 minus x squared. Let's square both sides. Pretty easy stuff. That's just going to make the square root go away. So 0 equals 1 minus x squared. Let's add x squared to both sides. So x squared equals 1. Okay, square root everything, positive or negative, and x equals plus or minus 1. So you are going to be negative 1, you are going to be positive 1, and I just now realized that it gave us that already. It already told us that. So whatever. So I'm going to integrate from negative 1 to 1, 10 minus 10x squared dx. Okay, the integral of 10 is 10x. The integral of negative 10x squared is negative 10 thirds x cubed. And my limits are negative 1 and 1. Okay, so I'm expecting a lot of repeats going on here. I'm expecting a lot of repeats. We got 10 times 1 minus 10 thirds times 1 cubed, close it, minus 10 times negative 1 minus 10 thirds times negative 1 cubed, close it. Okay, 10 minus 1 cubed is 1, 10 thirds is 10 thirds, so minus 10 thirds, minus negative 10 plus, and the reason why it's going to be plus is the cube of negative 1 is still negative 1, so negative 10 thirds times negative 1 is still positive 10 thirds. Okay. If I pretend that 10 is 30 thirds, then I get 20 thirds minus, and if I pretend that this is 30 thirds, then I get negative 30 or 20 thirds. And again, these are going to be the same because they're just the same. They're the same area underneath. So that's going to give me 40 thirds. So kind of a strange problem, but I liked it. The curves y equals x plus 4, y equals 4 minus x, and x equals 2 create a bounded region. Let's draw that out, shall we? X plus 4, look like this, goes through 4. 4 minus x is the same as negative x plus 4, looks like this. And x equals 2 is going to be like right there, and so you're looking at this guy, and you're going to fill that in. Nifty, 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 nifty. Each solid has cross sections perpendicular to the x-axis that are semicircles. Ooh, so semicircles, half circles. Looks like that. What is the volume of the solid based on the cross section? So essentially what's happening is you are creating like this weird semicircle, solid, triangular looking thing. I can't really explain it. But what we need to do is we need to find the diameter of each of these semicircles. Now let's think about the picture that we have here. This picture right here is x plus 4, and this picture right here is 4 minus x. We are creating semicircles with diameters that are going to be found by taking x plus 4 and subtracting 4 minus x. So let's say that diameter is found by doing the top part, which is x plus 4, minus the bottom part, which is 4 minus x. And of course, that diameter changes depending on what the x value is. So, right here, the diameter is nothing. But as you move up further away, move to the right, that diameter stretches, and it's all completely dependent on what's happening here. So let's distribute that negative. We have x plus 4 minus 4 plus x, cross you out. 2x is going to be what my diameter is going to look like. Now my radius is going to be half of that. Now why do I care about the radius? Well, give me a second. So my radius is x. God is good. Now what I care about is the area of this circle. Why? Because if I integrate the area of a circle, or better yet, semicircle, because that's what I'm focusing on, if I integrate that, I get the volume of the solid based on the given semicircle cross-section. Okay, so I'm going to find out that the area of a semicircle is going to be half of pi r squared. R in this case is x, so pi x squared. So let's integrate that with limits at 0 and 2. So 0, 2. We can pull the half out here. We can pull the pi out here and be left with just x squared. That'll make life easy. So the integral of x squared is going to be 1/3 x cubed. Okay, the 1/2 and the pi still living out there. My limits are 0 and 2 in that order. So I'm going to do 1/2 pi times 1/3 2 cubed, close it, minus 1/2 pi times 1/3 0 cubed, close it. Nice thing about this problem is you go away, and we are left with 1/2 pi times 1/3 of 8, close it, okay, which is 1/2 pi times 8 over 3, and that simplifies out to half of 8 over 3 is 4/3 pi. That's how you do it. The equation x squared plus y squared equals 49 represents a circle with a radius of 7 centered throughout the origin. Okay, so that's Algebra 2 pre-calculus stuff. This is what that picture looks like. If I knew how to draw it, thankfully the internet will save me. That's what we're dealing with here, 7, happy things. If the circle is revolved around the x-axis, what is the volume of the resulting solid? So we're taking this circle, spinning it around the x-axis, and we're going to get a sphere. So what we're going to do is we're going to use semicircles and cross-sections and all that fun stuff using this equation right here. In order for me to do that, let me take the equation and solve it for y. So that gets me that Let's subtract x squared minus x squared minus x squared. Cross u out. Y squared equals 49 minus x squared. Let's square root everything. Bada bing, bada bang. Positive or negative. And up here, y is going to equal positive or negative the square root of 49 minus x squared. Okay, so what that means is this y equation, so let's simplify it a little bit. This top part is the positive version of 49 minus x squared. This bottom part is the negative version of the square root of 49 minus x squared. Okay, and when we do semicircles, what we're doing is we're cutting this up into circular parts, and each red line here I'm drawing is the diameter of a semicircle that can be created. I know my picture is not that great, but these are each diameters. So to find the diameter, what you do is you take the top equation, the square root of 49 minus x squared, and you subtract the bottom equation, the square root of 49, the negative square root, of 49 minus x squared. That changes everything. Now what that does is that gives you a diameter of, double negative makes a positive, 2 square root of 49 minus x squared. Now that's good because the radius is going to be half of that. Why do I care about the radius? Because my job is to find the volume, and if I integrate the area, then I get the volume. So the radius is going to be half of 2 square root of 49 minus x squared, which cancel u out. The radius is the square root of 49 minus x squared. So finally, if we're doing semicircles, the area of a semicircle is half of pi r squared. So half of pi times the square root of 49 minus x squared, which is good because the square root and the squared cancel each other out, like so. That leaves me with, let's make this as clean and pretty as possible. I keep doing all these extra steps, which is fine. Half pi 49 minus half pi x squared, which is half, or 49 over 2, 49 pi over 2 minus, we'll just keep it like that, half pi x squared. Now what I need to do is I need to integrate that. What I do know is this is a circle, right, that goes out to all the 7s. So my limits of integration are going to be -7, +7. So I'm going to have the integral from -7 to +7 of 49 pi over 2 minus half pi x squared. Of course, don't forget your dx. All right, so not much to do here, but just to do it. You got 49 pi over 2, which becomes 49 pi over 2x, right? Minus, that would be 1/2 pi. X squared becomes 1/3 x cubed, so this becomes 1/6 pi x cubed, and my limits are at -7 to 7. So now let's plug stuff in. It's not going to be pretty. We get 49 pi over 2 times 7 minus 1/6 pi 7 cubed minus 49 pi over 2 -7 minus 1/6 pi -7 cubed. So basically we're going to get the same exact number, one's positive, one's negative, which makes sense because of the fact that this is a centered circle. All is well, everybody's happy. Now it's just a matter of doing some very, very, very gross, unhappy math stuff, which, you know, gross, unhappy math stuff is my middle name. It's actually Charles. What do we get? 49 times 7 is, I think, 343. I know you guys always comment when I make mistakes. So 343 pi over 2 minus 343 pi over 6, right? Because 7 cubed, right? And these guys are going to be the same exact numbers but flipped. So negative 343 pi over 2 plus 343 pi over 6. If I multiply the top and the bottom by 3, I end up with, or do I want to do 3? Think. Yeah, I guess I have to. That's 1,029 pi over 6 minus 343 pi over 6 minus negative 1,029 pi over 6 minus 343 pi over 6. And I'm just, because space is limited, maybe I can squeeze this down here. I'll keep going. I'll keep going. I'll feel guilt if I don't. That will be 686 pi over 6 plus 686 pi over 6, which is going to total out to 1,072 pi over 6. Both of those are divisible by 2, so 681 over 3 pi. Both of those are divisible by 3. I hope I'm doing the math right. I actually made a mistake. That's a 6. So I think we're done here. 686 pi over 3. Gross, yuck. The region bounded by y equals root x and y equals x over 3 is the base of a solid with cross sections perpendicular to the y-axis that are semicircles. We're doing a y-axis one instead of the x-axis one, which means we have to solve each for x and integrate with respect to y. So y equals root x, solving that for x is going to have me square both sides, and now I have x equals y squared, no big deal. Taking y equals x over 3 and solving that for x has me multiplying both sides by 3, and I get y equals, or x rather, equals 3y, no big deal. Okay, so if I pick one, it doesn't really matter which one. To find the diameter, if we're doing semicircle stuff, the diameter is going to be just the one subtracting the other. So we'll do y squared minus 3y, why not? Okay, so the radius is going to be half of that. So half of y squared minus 3y. Okay. So what is that? That's going to be half of y squared minus 3 over 2y gross. Now, if we're dealing with semicircles, the area of a semicircle is 1/2 pi times the radius squared. So 1/2 pi times 1/2 y squared minus 3 over 2y squared. Okay. Oh, this is not going to be pretty. That is a perfect square trinomial. So multiplying that to itself is, well, do I want to do that yet? I kind of have to. Multiplying that to itself, I should have not have done that. Oh, I regret doing that. That's too late. It's too late. I mean, what I'll do is I'll just wave my hands. And I'll say that the whole thing is going to be pi over 8 times y to the 4th minus 6y cubed plus 9y squared. Because time is money. Now let's integrate that. It looks like we have to find our limits of integration, so let's find that. It looks like it's from 0 to 8, but I don't want to guarantee anything. I mean, the picture looks promising, but here's the thing though. My limits are dependent on the y's, so I almost blew it right there. So it looks like actually 0 to 3. Let's just double check. The limits are when I take this or these two original equations, original equations, and set them equal to each other. So y squared equals 3y. Subtract 3y from both sides, so y squared minus 3y equals 0. Factor that out. Y minus 3, so yeah, we get 0 and we get 3, so those are our limits. Happy, 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 happy. What's not happy, 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 happy is what's about to happen. I'm going to integrate that guy right there. So let's rip out the pi over 8, go from 0 to 3 of y to the fourth minus 6y cubed plus 9y squared dy. All right, so the pi over 3 is going to still exist out there. You become 1/5 y to the fifth. You become negative 6 over 4, so negative 3 over 2 y to the fourth. And you become 1/3 times 9, so regular 3y cubed. And my limits are 0 and 3. All right, so we plug in the 3, pi over 3, 1/5, 3 to the fifth, minus 3 halves, 3 to the fourth, plus 3 times 3 to the third. Now, common sense would tell me that when I plug in 0, u becomes 0, minus u becomes 0, plus u becomes 0, which is all 0, and times that is 0, so you get 0. So let's not go crazy and write all that stuff out, shall we? This becomes pi over 8. 3 to the fifth is 243, so you're 243 over 5. So that is the same as 3 to the fifth, essentially, because it's 3 to the fourth times 3 again, so you're another 243 over 2. And you're 3 to the fourth, which is 81. Common denominator of 10. So let's multiply u by 2 over 2, so we have pi over 8. Multiplying u by 2 over 2 is going to get us 486 over 10. Multiplying u by 5 is going to be 1215 over 10. And multiplying u by 10 over 10 is going to be 810 over 10. Adding these three fractions up is going to get me 81 over 10. And multiplying these two guys together is going to get me 81 pi over 80. Yuck. Find the volume of the solid formed by revolving the region bounded by the curves y equals negative x plus 2, x equals 0, and y equals 0 around the x-axis. Leave this answer in terms of pi. So this is what we're dealing with. We're dealing with this equation right here graphed out, right? Okay, so what's going to happen is we're going to take this line. We're going to spin it around the x-axis, and by spinning it around the x-axis, we are creating essentially a cone that is going to be a solid shape. Okay, that's what we're doing here by spinning this around the x-axis. This method is called the disk method. And the disk method is calculated by taking the integral from your lower limit, we'll figure that out in a minute, to your upper limit, we'll figure that out in a minute, times pi times f of x squared. Now essentially what we're doing is we're saying pi times f of x squared. F of x, that black line right there, acts as a radius at different spots of our equation. So if you're looking at this and thinking, wait a minute, if f of x is like a radius, isn't that pi r squared? Isn't that the area of a circle? Yes, it is, because we're spinning something around. And when we take the integral of an area, we're finding the volume. So essentially what we're doing this is we're cutting this into infinite amount of circles, stacking them up as if they're disks stacked on top of each other, and calculating the volume that way. So what we need to do is we need to find our limits before we do anything. Now, our limits are going to be from 0 to 2. How do I know that's 2? Well, I need to find out what my 0 is, and my 0 is found by taking u, setting that equal to 0. So if I have negative x plus 2, set it equal to 0, add x to both sides, 2 is going to be my other limit. Okay, so I'm caring about this cone, essentially, from 0 to 2. So I'm going to set the integral from 0 to 2, pi times that function f of x, negative x plus 2 squared dx. So before I do anything, let's rip out that pi, okay, because it's a constant, or coefficient. This is a perfect square trinomial, so if you were to FOIL that out or do the whole perfect square things, you would get x squared minus 4x plus 4 dx. And now we can integrate. Okay, pi still lives out there. The integral of x squared is 1/3 x cubed. The integral of negative 4x is going to be negative 2x squared. And the integral of 4 is going to be 4x. Ooh, that was a close one. Oh boy, that was a close one. That was a close one. That was a close one. My limits are still 0 and 2. So let's plug stuff in. Pi times 1/3 2 cubed minus 2 times 2 squared, another close one, plus 4 times 2. Let's use common sense. If I were to plug in 0, I would get 0 minus 0 plus 0, which is 0 times pi is 0, so you're 0. We're not going to lose sleep over that. So now it's just a matter of doing that little bit of math right there. Pi times 2/3 is 8. So 2 to the third is 8, so that becomes 8/3. Okay, minus regular 8 plus regular 8. Oh, happy day, you cross out. So much crossing out. And at the end, we get 8 pi over 3. That's the disk method. Find the volume of the solid formed by revolving the region bounded by the curves y equals the square root of x equals 1, and x equals 4 around the x-axis. Leave your answer in terms of pi. So y equals the square root of x is going to look like this. What I'm going to do is I'm going to take this part to this part, and I'm going to take that little circular looking chunk, and I'm going to spin that around the x-axis. And what's going to happen is I'm going to end up with this weird bowl-like figure that's going to be a solid. But that looks just awful. But what we do get is this solid bowl-looking thing. So the method that we are going to use to do this is called the disk method. The disk method is found by taking the integral from your lower limit to your upper limit, so in this case from 1 to 4, and we're going to take the integral of pi times f of x, which is going to be the original equation that you're using, squared. And if you're looking at that and saying, wait a minute, that is kind of like pi r squared, isn't it? It is, because essentially what we're doing is we're cutting this part into infinite amount of circles and then stacking them on top of each other to find the volume. That's why this is called the disk method. All right, so setting this guy up means why don't we rip out the pi. My lower limit is 1, my upper limit is 4, and I'm going to square the square root of x. Oh, happy day. That's going to make life so easy because it's just going to be x dx. Okay, so the integral of x is going to be 1/2 x squared. My limits are still 1 and 4. That pi is still living outside. Now I'm going to plug in 4 and 1. So pi times 1/2 4 squared, a fun game, minus pi times 1/2 1 squared. You become, let's wave our hands a little bit, 4 squared is 16, half of that is 8, so pi times 8 minus 1 squared is 1, half of that is still 1, so pi times 1 half, not 1, but 1 half. That's 8 pi minus half a pi, which is going to be 16 over 2, 15 halves pi, or 15 pi over 2, which is B. Find the volume of the solid formed by revolving the region bounded by the curves y equals negative 1 half x plus 2, x equals 0, and y equals 0 around the y-axis. Leave your answer in terms of pi. Well, if we're doing the y-axis, we need to solve u for x. So that's going to be step number 1. Y equals negative 1 half x plus 2. Solve for x is going to have me subtracting 2 first. So that gets me y minus 2 equals negative 1 half x. Let's multiply both sides by negative 2. Multiply both sides by negative 2, so that's distributed property. Negative 2y plus 4 is going to equal x. So let's write it out that way. Okay? Happy day, happy day, happy day. So basically the picture that we're getting is going to be this equation, right? This equation spun around the y-axis. So we're looking at this like upside down cone looking thing that's going to be created when all is said and done. Okay, look at that picture. Perfect. So what do we care about? Well, we care about the fact that we're shutting this down at 0, and we need to find what this guy is going to be up here, which I already know, because that guy up there is going to be 2. That's my y-intercept. So my limits are going to be 0 and 2. So usually I focus on my limits being on the x values, but in this case I'm focusing on my limits being the y values because I'm spinning this around the y-axis. So my limits are going to be 0 and 2. Now this is using what's called the disk method. The disk method says we take our limits and we integrate pi f of x, or in this case f of y, squared dy. You are my new f of y. My limits are going to be a and b, which are 0 and 2, and I'm going to have pi, and I'm going to square everything. So let's set that guy up. Okay, let's rip out the pi. My limits are 0 and 2. I'm going to have negative 2y plus 4 squared dy. Let's pull out that pi. I already did. Pull out that pi. Before I integrate, let's FOIL that out. Okay, that's a perfect square trinomial. So you become 4y squared minus 16y plus 16 dy. Now let's actually integrate that. Okay, 4y squared becomes 4/3 y cubed. Negative 16y becomes divided by 2, 8y squared, and u becomes 16y with my limits living at 2 and 0, not in that order. Let's plug in 2. Pi times 4/3 2 cubed minus 8 times 2 squared plus 16 times 2. Now let's use some common sense. 0. Why? Well, if I were to plug in 0 into u, I'd get 0, and then you would be minus 0, and then you would be plus 0, and then timesing pi is still going to be 0, so nothing changes. I'm just left with this guy right here, so it's going to involve me simplifying stuff. 2 cubed is 8, so I have pi times 4/3 times 8 minus 8 times 2 squared, which is 4, plus 6 times 2, or 16 rather, times 2 is still 16 times 2. I don't know why I just didn't say 32, but I said no. You become pi over, not yet, sorry, jumping the gun. You become pi, what is that, 32 over 3 minus, oh, no way, 32 plus 32, so you guys cancel out, and you become 32 pi over 3. which is D. Isn't that fun? Find the volume of a solid formed by revolving the region bounded by the curves y equals 2 minus x squared and y equals 1 around the line y equals 1. Ugh, leave your answer in terms of pi. Alright, so this is what's going on here. We have this picture, 2 minus y squared. We're cutting it around here, and rather than spinning it around the x-axis, we're spinning it around here and creating this like weird shape that's going to look almost like a football, an oblong figure. Okay, so we're creating that. And since we're not spinning it around the x-axis, we're spinning it around another thing. We need to kind of use a reimagined version of the disk method. So the disk method is pi whatever squared. Okay, this is slightly different. The disk method around other axes is going to be the integral from a to b of pi, and then we're going to take our function that we're given, which is f of x, subtract the axis that we're spinning it around, which is g of x, and squaring that whole thing dx. So the f of x that we are going to use as our top part and the g of x that we're going to use as our bottom part are going to be these two guys right here. Now, before I can even begin this stuff, I have to find out my limits of integration. So my limits are going to be found by setting 2 minus x squared equals to 1 so I can find out where these two lines intersect. So why don't I subtract 1 to get 1 minus x squared equals 0. Why don't I add x squared so I get 1 equals x squared, square root everything, not forgetting my positive or negative, and my limits are going to be positive or negative 1. Okay, so let's set this god-awful mess up. All right, we have the integral from negative 1 to 1. Let's move the pi out front because I can. That is going to be f of x is 2 minus x squared minus g of x is 1 dx. Okay, don't forget to square it. That becomes pi from negative 1 to 1 of 1 minus x squared dx, which before we even integrate can be changed even further by squaring that whole parentheses, which is a perfect square trinomial. So 1 minus 2x squared plus regular x to the fourth, close it, dx it. Now it's time to integrate. Pi is still going to live out there. All right. The integral of 1 is x. And then we have negative 2x squared, which becomes negative 2/3 x cubed. And then we have x to the fourth, so plus 1/5 x to the fifth, with my limits existing at negative 1 to 1. Now we plug stuff in. Pi times 1 minus 2/3 1 cubed plus 1/5 times 1 to the fifth minus pi times negative 1 minus 2/3 negative 1 cubed plus 1/5 times negative 1 to the fifth. Okay, lots of same numbers are going to be repeated, just opposites. All right, pi is still out there. We get regular 1. This becomes 1, so times negative 2/3 is negative 2/3. This becomes 1, so times positive 1/5 is positive 1/5 minus pi. Okay, you're still negative 1. You become positive 2/3, and you become negative 1/5. Okay, common denominators of 15 are going to change that first bracket into 15 over 15 multiply u by the 5, so minus 10 over 15, multiply u by the 3, so plus 3 over 15, minus pi, do the same exact thing, you become negative 15 over 15, times u by the 5, so plus 10 over 15, and times u by the 3, so minus 3 over 15. 15 minus 10 plus 3 is 8, so we get 8 over 15 minus pi times negative, same thing but negative, 8 over 15. This becomes 8 pi over 15, double negative plus 8 pi over 15. Add the 8 pi plus the 8 pi, 16 pi over 15 is going to be our answer. Barf City. Barf City. Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared, y equals 0, and y equals 8 around the line y equals 8. No! Leave your answer in terms of pi. So what we're doing is we're taking a parabola and we're spinning it around 8. And we're going to get this weird oval-looking shape, pill-looking thing when all is said and done. So we are going to use the disk method, but around others, right? So the equation for that, the normal disk method is going to be integral from a to b, pi f of x squared. But since we're spinning this around a different axis, we're going to do f of x, the original equation, minus g of x, and then square that. So very similar, but not completely the same. Okay, so we need our limits of integration before we can do anything. So our limits are going to be found by taking the original equation here, x squared, and setting that equal to 8 so I can find out where x squared and 8 intersect. Oh, no way. This is going to be terrible. Square root, plus or minus, x is going to equal positive or negative 2 root 2. Ah! Oh, I hate it. I hate it. But thankfully, over here, we're blocking it off at 0. Okay, so I take it back. So we're not getting like a full pill looking thing. We're getting half the pill. So think of it as your doctor's telling you to cut your pill in half. It's a half medication. It's how I handle my anti-anxiety meds. So we're going from 0 to 2 root 2 on this one. 0 to 2 root 2. So let's set it up. 0 to 2 root 2. Let's rip the pi out front. We have f of x, which was x squared, minus g of x, which is 8. We're squaring the whole thing dx. That becomes pi from 0 to 2 root 2. That is a perfect square trinomial, so that becomes x to the 4th minus 16x squared plus 64 dx. Now we're free to integrate. Pi still lives out front. The integral of x to the 4th is 1/5 x to the 5th. The integral of negative 16x squared is negative 16 over 3x cubed. That's going to be a pain in the butt. And the integral of regular 64 is 64x. Your limits are still 0 and that god-awful 2 root 2. But fortunately, that 0 is going to make life a lot easier than having to deal with the other 2 root 2 that I originally thought we had to deal with. Pi is still going to be out there. 1/5 of 2 root 2 to the 5th minus 16 thirds 2 root 2 to the 3rd plus 64 times 2 root 2. Close that off. Minus 0. Why? Well, you plug in 0, you get 0. Minus, you get 0. Plus, you get 0. And then multiply to pi, you get 0. All right. Here comes the fun part. You ready? Here comes the fun part. Pi is still out there. 1/5 is still out there. 2 to the 5th power is 32 times. Root 2 5 times is going to be 4 root 2. Okay, root 2 times root 2 times root 2 times root 2 times root 2 is the square root of 2 twice, which is 2 times 2 times root 2, which is where I get 4 root 2, minus 16 thirds, a similar process. Okay, 2 times 2 is 4. No, 2 times 2 times 2 is 8, right? Root 2 times root 2 times root 2 is 2 root 2. Plus 64 times 2 root 2. Fortunately, I don't have to lose sleep over that one. So this becomes pi 1/5 times 128 root 2. I don't know why I put that up there. Let me move that down. 128 root 2. What was that? Minus 16 thirds. 16 root 2. Plus 64 times 2 root 2. (128 root 2 over 5) minus 200 and no, 256 root 2 over 3 plus 128 root 2. Multiply u by 3 over 3, multiply u by 5 over 5, multiply u by 15 over 15. I'm just going to wave my hands around a little bit. Okay, wave my hands around a little bit and just tell you what the answer is. And you're just going to have to trust me on this one. Pi is going to live here. Maybe we'll sneak the pi in right there. But boy, is that awful. Let me write that out one more time. 1024 pi root 2 over 15. When I created this problem, I made a mistake. I didn't want that to be 8. I wanted it to be 4, but I stuck with it, and I hope you stick with me because I love you. Thanks for watching. Find the solution for revolving the region bounded by the curves x equals negative y squared and x equals negative 4 around the line x equals negative 4. Well, boys and girls, this is the disk method around a different axis, and we're not spinning it around the x stuff, we're spinning it around the y stuff. So the formula for that is going to be the integral of pi f of y minus g of y squared dy, where your original equation is going to be f of y, and the axis that you're spinning it around is going to be g of y. Now, in order to find our limits of integration, what we need to do is set these guys equal to each other. So negative y squared equals negative 4. Common sense says, well, why don't we just multiply everything by negative 1, so you get that. Square root both sides, don't forget your plus or minus, and your limits are going to be positive or negative 2. So the equation that we're going to set up is we're going to set up ripping out the pi from negative 2 to 2 of f of y, which was negative y squared, minus g of y, which is minus negative 4, so plus 4, square the whole thing dy. Okay, when you do perfect square trinomial stuff in there, you'll get pi integral negative 2 to 2. This becomes positive y to the 4th minus 8y squared plus 16 dy. Now we can integrate. And that would be into great if we did. Pi, you become y to the 1/5 y to the 5th. That was a close one. Minus 8 thirds y cubed plus 16y. My limits are still negative 2 and 2. Now it's a matter of plugging stuff in. Don't make any math errors. You're going to see a lot of repetition because the same numbers are going to be used twice. Just one's opposite of the other. You get pi times 1/5, 2 to the 5th, minus 8 thirds, 2 to the 3rd, plus 16 times 2, minus pi 1/5, negative 2 to the 5th, plus 8 thirds, negative 2 to the thirds plus 16 times negative 2. What do we have? We have 2 to the 5th is 32, so 32 over 5 minus, all right, let's do this. 8 times 8 is 64 over 3 plus 32. And these numbers are going to be the same, just the opposite versions of that. Negative 32 over 5 plus 64 over 3 minus 32. Okay, common denominator of 15. So we'll multiply u by 3s, multiply u by 5s, multiply u by 15s. Or I could just wave my hands around a little bit and say, I promise you I know what I'm doing. Even though I make little errors, this is what we're going to get. We're at the very end of this, kids. We're like right there at the end. Let me be lazy. I made a lot of videos and my brain hurts. Thank you for watching, though. Love you. Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared and y equals x cubed around the x-axis. Leave your answer in terms of pi. Let's get a visual. All right, let's get a visual. Y equals x squared is going to look like u. Perfect. Y equals x to the third is going to look like u. So we have this tiny, 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 tiny little sliver right here. A tiny little sliver right there. And what we're doing is we're rotating it around the x-axis. And by rotating it around the x-axis, we don't get what we normally think we get. We don't get a solid like we did in the last couple sections. We kind of get this cup, this actual empty looking like a wine glass type thing is what we end up with. So we're not going to use the regular disk method that we're used to. We're going to use the washers method. Now this is called washers, just like the tool where you have the hole in between. That's kind of what we're dealing with here. We are dealing with a shape that is like a cup. It is solid, but the inside is hollow. So this is the washers method. The washers method is found by doing pi times the integral from a to b, and we'll figure out what a to b is in a minute. We're going to take your original equation, so labeling you f of x, right? Or whatever one is f of x. One of them is going to be f of x, one of them is going to be g of x. So let me not label things yet. Okay, we're going to take one equation, f of x, we're going to square it, and then we're going to subtract g of x, which is going to square that too, and then dx. So this is different from the disks method around a different axis because we're taking into account that hollowness right there. Okay, now according to the picture that I drew out, my top equation appears to be x to the third, and my bottom equation appears to be, or do I have it backwards? No, my top equation is actually x squared. So that's my top equation is going to be x squared. So you are going to be f of x, and you are going to be g of x. Now, does it matter? No, because what I get is like the same exact answer, but negative, and I'll just make sure it's positive because I'm not stupid. I need my limits of integration, though. And my limits of integration are going to be found by me taking these two equations and setting them equal to each other. So x cubed equals x squared. Subtract x squared from both sides. Factor out an x squared, giving you x minus 1. And you get 0 and you get 1. Those are my limits. So the equation that I set up for this problem is going to be pi times the integral from 0 to 1 of x. So I'm doing x squared minus x cubed squared dx. That's going to equal pi times the integral from 0 to 1 of x to the fourth minus x to the sixth dx. Now let's integrate that. Okay, 1/5 x to the fifth minus 1/7 x to the seventh, limits at 0 and 1. No big deal. Let's plug in 1. Pi times 1/5 times 1 to the 5th, easy peasy, minus 1/7 times 1 to the 7th, easy peasy, minus, let's use common sense, if I were to plug in 0, I get 0 minus 0, which is 0 times pi minus 0, so you get that. Pi is still living on the outside. 1/5 times 1 to the 5th is 1/5 times 1, which is 1/5. Minus 1/7 times 1 to the 7th is 1/7 times 1, which is 1/7. Did you catch all that? Now we have 1/5 minus 1/7, so let's multiply the top and the bottom by 7 and 5 respectively. Well, 7/5, 35ths minus 5/35ths is going to be 2/35ths, and 2/35ths times pi is 2 pi over 35. Dog. Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared and y equals x cubed around the y-axis. No, leave your answer in terms of x or pi or whatever that is. All right, we did a very similar problem in the last problem. Those of you who watch all my videos in order religiously know what's going to happen. Okay, you graph y equals x squared. I'm still graphing it like that. You graph y equals x to the third, and that happens. You have this neat little sliver that's going to take place in between. Now we're spinning it around the y-axis. So by spinning it around the y-axis, you basically get a hollow bowl. So this is going to require the washer method. Okay, the washer method, and by the way, this is, around the y-axis, if we're dealing with y's, the washer method is going to be pi times your integral from limits of a to b, we'll figure that out when we have to, f of y minus g of y, square both of those, dy. All right, so what I need to do is I need to solve both of these for x before I do anything. Solve both of these for x. So I'm going to I'll do that over here where I have a little bit of space. Y equals x cubed and y equals x squared, square root, cube root, right? This becomes x to the, I'll write it out as y to the 1/3 because I'm going to need to write it out that way anyway. And this will be positive or negative, so I'll write this out as x equals positive or negative y to the 1/2. Now the positive or negative part's just going to go away. You'll see why in a little bit. Although, it doesn't really matter because I'm spinning it around. So these are my two equations. All right, these are my two equations. Let's set this puppy up. Do I have my limits yet? No, I don't even have my limits yet. Ugh. All right, so my limits are found by setting these guys equal to each other. So y to the 1/3 equals positive or negative y to the 1/2. Why don't I do this to make my life easier? And to the 6th power both sides. So you become multiply the exponents, y squared. You become multiply the exponents. Anything to the 6th power is going to become positive, so y to the 3rd. Subtract y squared from both sides, so I get that. Factor out y squared, so y squared equals y minus 1. And my limits are going to be 0 and 1. So now I can finally set this thing up. So pi times 0 to 1's integral of 5y squared. So I think I'm going to use let me see, the outer one would be the cube. So I'm going to do y to the 1/3 squared minus positive or negative y squared, or to the 1/2 squared dy. You become pi integral from 0 to 1 of y to the 2/3 minus, you essentially cancel out, and so do you, just y dy. That becomes pi times 3/5 y to the 5/2, just reciprocal stuff, minus 1/2 y squared with limits existing at 1 and 0. Okay, pi still lives there. Plug in 1, 3/5 times 1 to the 5/3, which is going to be 1, minus 1/2 times 1 squared, which is also going to be 1, minus, if I plug in 0, you become 0. If I plug in 0, you become 0. 0 minus 0 times pi is 0, so that makes life easy. You become pi times 1 times 3/5 is 3/5. 1 times 1/2 is 1/2. Okay, multiply u by 2 over 2, so pi times 6 over 10 minus, multiply u by 5 over 5, 5 over 10, and you're going to end up with pi times 1/10, which is pi over 10. Breathe in, breathe out. Washers. Find the volume of the solid formed by revolving the region bounded by the curves y equals x, x equals 0, and y equals 0 around the x-axis. Leave your answer in terms of pi. I intend to. Let's draw this out. Let's draw this out. Y equals x, easy. Y equals 0, that. Or x equals 0 is the y-axis, that. Y equals 3 is that. So we have 3, we have x, and we're spinning it around the x-axis. So by spinning this around the x-axis, what we're doing is we're creating this weird circular shape that I will absolutely do a terrible job drawing out. But that's what we're going to get. I'll give myself some credit. That's not that bad. But what this is going to require, since there's space in between, is the Washer's method. Now, the Washer's method is found by doing pi times your integral from a to b of your upper radius f of x squared minus your lower radius g of x squared dx. What I don't have right now are my limits, except for the fact that I kind of do. You're 0, and if x is 3, then x is 3. So I have my limits already. So I can pretty much say, all right, well, the 3 is going to be my top part, so you're going to be my f of x. You're going to be my lower part, so you're g of x. And this problem is not going to be super bad. So pi, I mean super bad compared to some other problems that could erupt. 0 to 3. I called f of x 3, so 3 squared. I called g of x x, so x squared dx. So you become pi 0 to 3 of 9 minus x squared dx. Now we can integrate. Leave that pi out there. Pi times the integral of 9x minus 1/3 x to the third. Limits are 0 and 3. Plug in 3. Pi times 9 times 3 minus 1/3 of 3 to the third power minus, common sense says if I plug in 0, I get 0 minus 0, which is 0 times pi, which is 0, and 0 is what I get, 0, 0, 0. So pi times 27 minus 3 squared is 9 times negative 1/3 is 3. No, 3, that should be 3 cubed. Ah, that was a close one. Oh boy. Oh, so 3 cubed, oh boy, is 27. 27 times a third is 9, so 27 minus 9. Oh boy. Oh, pi times 18. 18 pi. Phew. Set up an integral to find the volume of the solid formed by rotating the region enclosed by the curves y equals the square root of x and y equals x squared about the line y equals 2. Ooh, all right. So we got one guy, we've got another guy, and we're rotating it around something up here. I don't even know if that line is accurate. I don't even know if it's accurate at all. But this is what I do know, is this is the Washer's method all right, surrounded or spun around a different axis. So this is taking all the horrible stuff we learned in the last like 4 sections and putting it all together. So the washer's method using this way is going to be like the regular washer's method. Okay, and it's washer's method because of that space in between. The regular washer's method is so the integral from a to b, don't forget your pi out front. Okay, now what we're going to do is we're going to take a minus f of x. Now if you're wondering what a is the line you're spinning it around. So a minus f of x squared minus the same a minus g of x squared dx. All right, so I'm going to label the fact that the upper guy seems to be x squared. So you would be my, or no, the upper guy, I take it back, seems to be the square root of x. So you would be my f of x. You would be my g of x. So setting this up is I need my limits. So I find my limits by setting these two equal to each other. So let's, before we even set things up, let's make sure that, I know the limits are 0 and 1, but what if this wasn't multiple choice and you actually had to figure this out? All right, set these guys equal to each other. The limits are going to be the square root of x equals x squared. Why don't we square both sides, right? So that we get x equals x to the fourth. Subtract x from both sides to get x to the fourth minus x equals 0. Factor out an x to get x to the third minus 1 equals 0. And then you can see that your limits are going to be 0 and 1. So putting all this together, pi 0 to 1, parentheses, parentheses, a is going to be my 2. So 2 minus f of x is going to be the square root of x. So the square root of x squared minus 2 minus g of x, which is x squared, squared, close it, dx. And the one that seems to match that is C. Oh, I hate it. I hate it. Wait till the next one where we actually do the problem. Find the volume of the solid formed by rotating the region enclosed by the curves y equals x, x equals 0, and y equals 3 about the line y equals 4. This is using the washer method around a different axis. The equation for that is pi times the integral from a to b of whatever line you're rotating it about minus the upper equation, close that, square that, minus whatever line you're rotating it about, minus the lower equation, close it, square it, dx it. Okay? So, if I were to graph this, okay, y equals 3 lives right there, y equals x lives right here, okay, and we're spinning it around y equals 4. So what's going to be created is this weird like triangular looking thing. So basically you have that spun around, right? And you have this weird triangular looking object that's spun completely around. Okay, this would be like half of it. If I were to cut it in half, that's what it would look like. Okay, so yes, this is the washer's method. Now, according to this picture that I have, okay, this is my enclosed region and I'm spinning it around 4. My upper equation is going to be the 3, so you would be my f of x. My lower equation is going to be my x, so you would be g of x, right? I'm shutting you off at 0. You guys intersect at 3, so those are going to be my limits, so that's my a and that's my b. And I'm spinning it around y equals 4, which is going to be that a in there. Probably a poor choice by me using a twice, but that's all right. God will forgive me. So the integral that I can set up is going to be pi from 0 to 3 of 4 minus 3 squared minus 4 minus x squared dx. So pi from 0 to 3 of, thank you Jesus, 1 squared, I can handle that, minus perfect square trinomial, is going to make that look like 16 minus 8x plus x squared dx. Distribute that negative. So pi 0 to 3, 1 minus 16 plus 8x minus x squared dx. Pi integral from 0 to 3, combined like terms, negative 15 plus 8x minus x squared dx. I haven't even integrated yet. That's the fun part about this problem. But here I go. Now I can integrate. Pi is still living out there. The integral of negative 15 is negative 15x plus that'll be 1/2, so 4x squared. And that'll just be minus regular 1/3 x cubed with limits at 0 and 3. Let's plug in 3. Pi times negative 15 times 3 plus 4 times 3 squared minus 1/3 times 3 cubed. If I plug in 0, it would be me plugging in 0 and getting 0 plus 0 minus 0 times pi, which is 0, so you get 0. Pi still lives on the outside. Negative 15 times 3 is negative 45. 3 squared is 9. 9 times 4 is 36. 3 cubed is 27 divided by negative 3 is negative 9. All of that becomes negative 18 pi. So that's what this means is I chose the wrong f of x and the wrong g of x. No big deal. The quick fix is just make it positive. And you get 18 pi. Yum, yum. 18 pi sounds like a good Thanksgiving to me. Thanks for watching. Please send help. The last problem of AP Calculus. Are you ready? The area bounded by the graphs of y equals negative 2x plus 6, y equals x, and x equals 0 is rotated around the line y equals negative 1. Use the washer method to write an integral and find the volume. So it's telling us what to do. We are going to actually use that washer method, so I'm just going to trust you. But here's the thing. I'm spinning it around y equals 1. So the equation that I like to use for the washer method is I have pi living out here. I have my integral from a to b. Okay, and I'm going to set up a, which is going to be the equation that I use, minus f of x, which is going to be my upper equation, squared minus a, minus, again, the same a here, minus g of x, close it, square it, close it, dx it. Okay, so I'm going to allow u to be my f of x, because why not? I'm going to allow u to be my g of x, because why not? And I'm going to let u be my a. What I don't have are my limits of integration, so let's find my limits of integration by doing these two guys set equal to each other. So negative 2x plus 6 equals x. Add 2x to both sides, add 2x to both sides. 6 equals 3x means that I have divide by 3, x equals 2, and I'm already told that x equals 0. All right, so let's set this up. I got pi times the integral from 0 to 2. I have a, which is negative 1, so negative 1 minus negative 2x plus 6. And then we're going to square that. So I'll probably need another set of parentheses there. And move that parentheses out because it looks sloppy. Much better. Minus negative 1 minus x squared. Let's scooch u back in. Let's dx u. So that's going to end up being pi times the integral from 0 to 2 of, let's kill two birds with one stone to make life easy. That becomes negative, so that's 2x. U would become minus 6. Okay, so minus 6 minus 1 is minus 7. So that guy squared. I did it again with the parentheses. What's wrong with me today? Minus, why don't I perfect square trinomial that right now, so you get 1 plus 2x plus x squared. Okay? And then close that, dx that. Why don't we perfect square trinomial that, and you get 4x squared minus 28x plus 49 minus, while we're at it, why don't we distribute the negative here? 1 minus 2x minus x squared dx. So we could still do a lot of combining before we even integrate. So 0 to 2 is still there. Pi is still there. Can't forget that. 4x squared minus x squared is 3x squared. Negative 28x minus 2x is negative 30x. And then 49 minus 1 is 48. Still haven't integrated yet, until now. So you become pi times x cubed, perfect, minus 15x squared plus 48x. Limits are 0 and 2. Pi times 2 cubed minus 15 times 2 squared plus 48 times 2 minus, plug in 0, you get 0. Pi times, you become 8, you become minus 60, you become plus 96, and when all is said and done, 44 pi. If you stuck through it with me, thank you for watching. I love you guys. You're the best. Good luck on your AP exam and in life. And yeah, thanks. Love you.